Today, we are going to learn how to construct and interpret a two-wave frequency table. We have already learned how to use a scatter plot to see if there's some sort of correlation. Sometimes there's a pattern between things, but we can't make a scatter plot about them. We're going to learn how to make what's called a two-wave frequency table, where a scatter plot deals with numerical data. A two-wave frequency table deals with what's called categorical data. It will talk about categories, and it's a great way to organize our thinking and to see what trends appear. So categories are things like in this table, what gender you are, and where you choose to go on a field trip. Let's read the problem and see what happens. 100 students were going on a field trip. 45 of them were girls. The students could choose between the Clark Planetarium and the Capitol Theater. Sounds like a fun field trip. 60 students chose to go to the planetarium, 35 of which were boys. Make a two-way frequency table to display this data. What's nice is that all of the information that was given to us is already written in the frequency table. You can see where the total number of students who chose to go to the planetarium is. It's 60, and it also says 35 of which were boys, right? You can also see that there were 100 total students who went on the field trip, and 45 of the total were girls. They're all in the places. Now we can use our frequency table to organize our thinking and to figure out what all of the categories have, how many people were girls who went to the planetarium, how many boys went to the theater, etc. Here are a couple things that you should notice. Notice that each row and column has its own total. So we'll have a total number of boys, of girls, of children who went to the theater, and of children who went to the planetarium. You should also notice that the last row and the last column should have the total. So all of the numbers should add up to equal 100. So this is kind of nice because everything's going to add up together. Let's see what happens. I'm going to go ahead and fill in my missing information, and I just noticed right off the bat, if there are 35 boys and 60 total children who went to the planetarium, then 60 minus 35 is 25 girls, so 25 girls went to the planetarium. And that's pretty much how you're going to fill in the entire table, is you're going to find where there's two pieces of information to find the third. So let's look here. We have 100 students total who went on the trip, and 60 of them went to the planetarium, which tells me 40 of them went to the theater. Now, be aware, if we were to try and fill in this column, fill in those boxes without looking at anything around, we'd have to guess at this point. We'd have to be like, I think 10 boys went to the theater, so then there's 45 boys total. Well, that doesn't make any sense because 45 plus 45 does not equal 100. So we can't just pick numbers willy-nilly. We have to go and find missing holes and be able to subtract or add to find that information. So I have 25 girls who went to the planetarium. Here's a column with two numbers so I can find the missing one. And that tells me 20 of them went to the theater. Okay, let's find another row or column with two pieces of information. Here's a row. I have 40 total who went to the theater, 20 girls, 20 boys. And then this last box, you can pick whichever numbers are easier for you to deal with. I think 35 plus 20 is easier to do, so I'll say 55 right there. So you're going to be adding and subtracting to find your information. You'll add the numbers to find totals, and you'll subtract to find anything else. Anything that's not a total. So now we can answer some information based on what we found. Was the planetarium or the theater more popular? So I'm going to look at my totals for the planetarium and the theater, and it looks like the planetarium was more popular. What can you say about the students who went there? So to the planetarium, we had 25 girls and 35 boys. So there were more boys who went to the planetarium. And for the theater, it was equal equal numbers. So equal boys and girls. Now let's go down to the bottom of the page, and we have an example. We have to complete two different charts. We have to complete what's called a two-way frequency table and then a relative frequency table. A relative frequency table is just like a two-way frequency table, except everything adds up to 100 or 100%. This is really useful when you're dealing with really gnarly numbers. Sometimes it's easier to just change everything to a percent. You can tell which one is which by looking at the symbol at the top of the table, or you can just look at the numbers and go, well, those don't all add to 100. It must be just a frequency table, not a relative frequency table. Okay, so when you're asked to create both, you should always fill in your frequency table first. Then you can use your frequency table to fill in your relative frequency table. Okay, so I should probably read this. 8th grade students were asked whether they did homework after school. So yes is yes, they did homework after school. No is no, they did not do homework after school. And then their gender was taken into account, whether or not they were male or female. So I'm going to look just for columns and rows that have 2. So we have 80 male and 200 total, so 120 of those were female. I just subtracted because it's not a total. We're trying to find 170 minus 80 over here, so that's going to be 110. And then we're trying to find, okay, here's a twoer. 350 minus 170. I don't know how much that is. I think it's 180. Yeah, it's 180. You could also use a calculator. Okay, and then, I have a row of 2 right here. 120 plus 60 equals 180. And you can either choose to add or subtract to get that final box. Adding is easier for me, so I'm going to say 170. And to check my work, let's just make sure that 170 adds up to 350. Oh, I don't think it does. I made an error. Okay, so I made an error because 200 plus 170 is not 350. It's actually 370. So let's erase this. And while we're at it, let's erase these guys. Okay, I have the 80 and 170. They were printed. So 80 plus what is 170? It's not 110. It's going to be 90. 80 plus 90 is 170. There we go. Okay, this 120, it makes sense. And that 180, it makes sense. Okay, now we can keep going. 120 plus 60 equals 180. Okay, here we go. 90 plus 60 is 150. Now it all adds up. Okay, be sure to check and make sure that all of your numbers add to the totals. Every single total makes sense. Okay, now to find our relative frequency table, we're going to find the percentages. So we know that it's all going to add up to 100% total. And if you don't remember how to find your percentages, you should divide your numbers by the total. There are different ways to do relative frequency tables. You can find percentages of the males and percentages of the females, but we're just going to find the percent of the total surveyed. So we have, I'm just going to write my calculation. I'm going to put each number over the total. So 80 over 350. 120 divided by 350, 200 over 350, 90 over 350, 60 over 350, 150 over 350. So you divide them to find out the percent, and then you can either multiply by 100 or just read it up until the hundredths place to find the percent. 350 180 divided by 350. Okay, so now we have all of those numbers. Now we're going to find our percents by dividing. Okay, we have over 80 divided by 350 is 0.228. Now remember, to find the percent, you could multiply by 100. Oh, that didn't work out very well. Hang on. We have an error. Okay. times 100. You could either times by 100 at the end, or you could just read it 22.8. Just move the decimal over 2 places. So 22.8, that rounds up, so 22.9, but to the nearest tenth, because sometimes they're right in the middle, and the nearest tenth will be a little more accurate. Okay, do I have anywhere else with an 80 out of 350? No, I don't. Okay, so let's go back and do 90 out of 350. Okay, 25.7%. Okay, 170 divided by 350. 48.6%. $120 by 350. 34.3%. Okay, 60 divided by 350. 17%. Oh, 100, 200, and 150. I decided to do it this way. It was easier. Okay, 180 will be 51.4%. And that does add up to 100. 200 was 57.1%. 150 was 42.9%. Okay, let's make sure all my percents add up. I checked this row and it works. Let's check. I'm going to do yellow highlight. This row, 57.1 plus 42.9. Yeah, that makes sense. Now there might be one that is slightly off, like this one. It's actually 57.2 is what it adds up to. So sometimes there's going to be a slight rounding error because some of them don't divide evenly. And then this one is slightly off in the other direction. So as long as it's within 0.1%, you're going to be pretty good. Okay, so now we can say what is the relative frequency of females who do homework after school. We can just go look at the table. Females who do homework after school, 34.3%. And then the relative frequency of males who do not do homework after school. And it says table because it's referring to the percent of those total surveyed. It's going to be different if it says what percentage of males do not do homework after school. Then you'd have to calculate it with the total males. So then you'd have to do something different. I'll show you what it would be like in a second. But I'm just going to read from the table. Who do not do after school? 25.7. Oh, whoops. Let's undo that. Okay, 25.7. So if it asked you percentage of males who don't do homework after school, you couldn't use that 25.7% because it's counting males and females. So you'd have to go over here and just divide 90 by 170. And 90 divided by 170 is a much larger number. Let's actually find that out. 90 divided by 170, 52.9%. So you got to be careful. Read the question well. If it asks you the percentage of males, then you need to divide it with the total males, not the total of the table. All right, good luck.